Okay. So for the current meter reading, that will give us the velocity, and the midsection method that will give us the area calculation. And here, N is the revolution per minute, like in water per second, how many times the current meter is rotating. Okay. Now from here, we will move to the Excel, but make sure you have your paper copy in front of you. Or if you want to draw on your Excel copy using something, you can do that one as well. Okay. So all of you have this one, something like that. Okay. So a little bit less color on your copy, I guess, because I just colored that based on my section 1 experience. Okay. So here, let's discuss a little bit about what data set we have. So it says that distance from the initial point. Are you seeing that one? Distance from the initial point, 10, 12, 14, 17, 19, 21, 22, 25 meters. So when I say distance from the initial point is this one. That is the initial point. Or 0. Okay. So 10 means section number 1. That is actually 10 feet away from that initial point. So what I will do, I will name each section. You can add one more column or something. I will name each section as 1, 2, 3, 4, 5, 6, something like that. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. You can add one additional column and write down 1, 2, 3, 4, something like that. And what I will do on this one, I will try to draw straight line here for each point. Okay. Can you draw that? All the straight line at each point, and then name that as 1, 2, 3, 4, just like you did on the table. So it will be 1, 2, 3, 4, 5, 6, 7, 8. Do you have that? Like you can do that in your copy. Okay. Now, for each section, we know the distance from the initial point, right? 10, 12, something like that. We also know the depth for each section as well. Okay, great. Now, our main objective is to find Q equals to summation of these ones, right? So what we will do, we will try to find out velocity and area for each subsection. Now, how can we divide the section, which you already did? We just added different points, like 1, 2, 3, 4, 5, 6, something like that. And those are actually our subsections, right? Okay. Now, are you seeing for each station number, like 1, 2, 3, 4, we are having some information about the revolution and over time. Okay. Now, for the section number 1, what is the depth? 1. And there is no information from the current meter, right? That's because 1 feet is like very small depth, like that one. The current meter can't take reading on that small depth. So what we will do, we will take the velocity from the adjacent section. But for doing that, we need to calculate the velocity at adjacent section, right? Now, are you noticing section number 2, 3, 4, 5? Each of them has actually 2 points, like in between, in 2 different locations where we have the current meter reading. All of you, have you noticed that? And also, have you noticed that for 2, 3, 4, 5, the depth is actually greater than 2.5? Have you noticed that? So whenever the depth is greater than 2.5, we will have 2h and 0.88 velocity. And that's why you have 0.2, 0.8, 0.2, 0.8, 0.2, 0.8. Are you seeing that? All of you can notice? Okay. So, and for 6, 7, 8, that section, what is the depth? For 6, 7, 8, all of these are actually less than, D is less than 2.5, right? And here, D is more than 2.53. Okay. Now, since our objective is to find area and velocity, we will do that. But I think our very first step should be to set the table heading. So let's do this way. That's how I set the table. Okay. And for the velocity, what you will do? Do we know any equation for the velocity? 0.1 plus 2.2 n. N is what? Revolutions per second. So, like column D over column E, that's the n, right? Okay. Can you check your number for the first two, if you got this number or not? All of you? From that, you can see the number on the screen. Okay. 0.1 plus 2.2 n, and the n should be n is column B over column E. Do you have this same number? You don't have that? Yeah. Yeah. 2.2 multiplied with n, and you have 1.1 in front of that. Did you use this? Okay. Okay, if you got these two numbers correct, scroll down till the end and you will have the velocity for each location, okay? You have this velocity, everyone, on your copy? That's what is in the equation here, 0.1 plus 2.2 n. You see the velocity. Does that make sense? Okay, class, those who are done with this one, you see the next column is mean velocity. That means for which section we have two points, we need to find out the mean velocity. Okay, can you do that? So I arrange the cell in a way like whenever you have 2 points, you will have the average for those 2 points. Okay. So check that if you have this velocity, the average velocity on your Excel copy or not. You have that, all of you. Anthony, you got that? This number? in the width, this one is actually distant from the this one. It would be just this is the one. And the effective width is this one. What we will do is need to do that with manually like half of W2 and yeah, actually that's yeah. That is okay. Yeah. Yeah. The first one, let's name actually this one. This one to this one. This one. Yes. 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 Exactly. Yes. Yes. That's right. Okay. Class, what should we do about the section 1 velocity? I don't have any current meter reading for this one. What should we do about section 1? It will be not exactly 0 because still there will be velocity. Because it's 1 meter, it's just too close to the edge. It will be not with 0. There will be some velocity. And if you check your class note, we said that whenever we can't find the current meter velocity for any location, we will check 65 to 90% of the adjacent velocity. So what is the adjacent velocity? This one is 1.354, right? Now 1.354, I will check some value in between 65% to 90%. Now the question is what percentage I will check. Now that actually depends on most of the time field observation, which we don't have here right now. So unless I state any specific percentage, we will always use 65%. Okay. But if I mention something, take 75% or 90%, something like that, you will do that. But if I don't mention anything, we will check 65% of 1.34. What is that number? What is that number? 65% of 1.344. Did you get something 0.88? Yeah, so I will just make a note that this one is the 65% of 1.354. Okay, great. So now we have the velocity for each section. What is the next part? Find out the area, right? Now for area, which method we should use? There are multiple methods, but which one we use? Is there any specific instruction in the statement that what type of area calculating method we need to use? The midsection. Now, for the midsection, as we discussed, all of these current meter locations that should be at the middle of the section. That means we need to check a section, half of the previous, half of the next one. Okay. So how can we do that? If you have different color, use that, or you can just use the dotted line to find out the center line for each section here. Can you do that? Okay. And what I will do, I will actually extend this solid line . I will name that 1, 2, 3, 4, 5, 6, 7, 8. So now what we will do, we will find out the area for each current meter location. So for section 1, what is the area? Only this portion? Just the half of the next section, right? Because there is no previous section. For 3, half of this one and half of the next one. I will come to 2 because I will just use a different color for that. But for 3, does that make sense how we are actually finding the area? Everyone? No question, no confusion. We know how to do that. Okay, we will measure what is the depth or something, but let's discuss the concept first. So the next section is this one. The next one is this one, right? And for 2, I will use a different one so that okay. So for section 2, that is the section 2. That is section 4. That is section 6. That is section 8. Does that make sense to everyone, like what we're doing here? Okay. Now our task is we need to find out, okay, what is the width for this section, because we already know the depth for each section, which is 1, 3.5, 5.2, 6.2. So we already have the depth, but we don't know the width. So the way we will calculate width, what I said width for each section and the effective width, okay? So when I said width for each section, I meant this one. Like in between 1 to 2, what is the width, okay?
What's the
Yeah, what is your question, Michael?
why are they labeled blue?
Which one?
Like up from the actual card itself.
This one?
Yeah, like why are they like blue instead of blue?
Blue, green, blue, green?
Yeah.
Oh, the only reason, because for the last section 1, we like while we are doing calculation, we got confused, like which section has 2 points and which section has 1 point, something like that. Like if you look at the section 12, it has 2 points velocity. It's just for visual purpose, no specific reason. That's why, like for 14, we have 2 sections. For 17, we have 2 sections. So I just use same color for those 2 sections. Okay. Now, for width for each section, what is the width for section 1 and 2? That will be 2 because that's 12 minus 10, right? What will be the section in between 2 to 3? 3 to 4? So you know how we are doing that, right? So can you find out the depth? Can you find out the width for each section? Is that the one? All of you got. Everyone, please check if that is the number you got. So what I will do, I will say it's 10 minus 10, 2 is 14, 12 minus 10, 14 minus 12, 17 minus 14. So that is kind of the number. Now, when I say the effective width is for the area calculation. The effective width will be, what is this one? can you help me with this width? What will be the width of the actual section here? The pink color one. Up to this point, what is this value? Just this one. Half of section 1 and 2, right? Which will be 1. Okay. What about this one? This one is 1. What is the half of this section? 1 plus 1, right? But does that make sense? What we are doing, we are taking half from the previous section, half from the next section of each current meter location. So 2 is the current meter location. The previous section has width 2 and the next section has the width 2, right? So what we are doing, 1 from previous section, 1 feet from the next section. Or if you want to calculate, just calculate the width of each white and blue and yellow section. That's the width, effective width, basically. So what is that one? 1 plus 1.5. 1.5 plus 1, right? So what we are doing here, actually, we are trying to find the width of all the yellow and blue color sections. Okay. Now, how can we do that? We know what is the width of, like, in between the stations. We just did that. So the effective width is always half of the previous section, half of the next section, right? Last bench, does that make sense? Okay, good. If it makes sense, check if you got this number or not. All of you, did you get that number? So this one is, okay. This one is 2 over 2. This one is 1 plus 1, 1 plus 1.5, 1.5 plus 1, 1 plus 1. Those of you who got up to this point, can you calculate the area with times height and then the discharge equals to AV? And those who are still starting, I can help. Trying to find this. So what is the one and two? This one is from 10, 10 minus 12. So this is 2, right? But you are looking for half of that. 2 is 1. Okay. Not all of these, because there is one section. That's the one. Okay. The next one, consider which one from this section here and one. The one. I know, that's why oh, you don't have to. Okay, class. So if you have this one, can you calculate the area and the discharge for individual section? Area will be what? Effective width multiplied with depth. Do we know depth for each section? It's given, so you can just find out this way. And what will be the velocity? Discharge. Q equals to A times B, right? Do we know the velocity? Column G, that is the mean velocity, right? Now, all of these is just for each individual section. If I want to find out the total flow, what I need to do? We need to make the summation because 0.8801 is only for this yellow section. 0.9478 is actually for this blue section. So I have the velocity for each, the discharge for each section, but I need to find out the summation. Can you make the summation? And tell me what number you got. It should be something around 72, I guess. If you do all the calculations. Yes, 72. All of you got that, 72.4382. And the discharge should be feet cube per second, not only feet cube. So fix that one. Okay, that is the class example 22. Like using the mid-section method. There can be another version if I say use the mean section method. The only difference will be that time you need to calculate the area for in between the current meter, and that will change a little bit, but not that much. Okay.
You want to use velocity or mean velocity?
Now or
For the discharge?
For the discharge, it will be the mean velocity. Because the velocity, in that case, you will have two velocities at 2 points. Okay. So all of you have that number 72.43. You have all the notes I wrote on the screen. Did you save that in a safe location? Okay. So that's it for class example 22. I'll be happy to answer any question. Yes.
Can you give like, how did you get the effective width?
The effective width. Okay. So the effective width is what is actually the effective width for this section 2. Okay. So the 2 here, if you look at the blue line, 2 is actually the center, right?
Mm-hmm.
That means half from the previous section, half from the next section. Does that make sense? Half from the previous section, like this one. You have question or you just writing? Okay. So Q equals to AV. So you have area and velocity for each section. So you will just multiply.
By the mean velocity.
Yes, and the area. Michael, did you get how did you calculate the effective one?
Yeah.
Okay. Are we good? All of us? Okay. So please save that. And what we will do, we have 8 minutes. So we will just start our second class example 23. And that's, I don't think we'll be able to complete that, but that's okay. Okay. So till now, what we did, it was actually the direct measurement, right? Like we directly measured the velocity and the area of intersection. Now the next one, which is the stage discharge curve method, we will use, this is the indirect method. Okay, so we don't have any direct measurement, but from the equation or something, we will do that. So that's the thing. It's the rating curve. That is the indirect method. Now, can you help me by providing the stage discharge equation, like the general stage discharge equation? You can get that from your class note. What is that equation? Okay, thank you. This one, right? Now, are you seeing any statement in the question about any datum correction or something? They didn't say anything about datum correction or anything, right? So we will assume that the A is 0. Okay. That means the equation becomes Q equals to A h to the power n. Now, when they say find the equation of rating curve for the Saluda River South Carolina for the following measurements using a graphic procedure, have you noticed the graph is actually the log, right? And here we have the equation Q equals to AHN. So what we need to do, we put that Y, something called constant, we need to find A and N values. Now, once we have A and N, we can find the distance for any height, right? Does that make sense? That we equals to something H, N. So if we know the value or if we know the exact equation for one unknown X, we can find the Y value, right? So our task for this class example is we will find out A and the N value. Up to this point, did you get that? What I'm just saying, everyone? We need to find out A and N values. Now, since this one is the log curve, what I will do, I will convert this equation into log as well, so that I can use this chart to find the value, okay? So what we will do, Q equals to A h to the power N. That means we have log Q, log A, N log H. Little bit of your pre-calc. How many of you took Math 114? Okay, you didn't have to tell me, but that was a pre-calc, right? Okay, now if I just convert that into a different way, not different way, just if I just express in a different way, what is that equation? Y equals to C plus mx. Straight line equation, right? Okay. That means if we use the given data, that looks like kind of straight line, right? So if we can find some value from that one, we will be able to develop our rating curve, right? Now, have you noticed something in the plot? It's the stage which is H and here it's Q. So it's actually just opposite whatever we have in our equation, right? So that M is the slope, we know that. But in this case, the N will be 1 over slope for this specific plot. But we need to make sure that we understand why we are using N equals to 1 over slope, not the exact slope. That's because this equation was Q equals to something, but if you look at the plotting, it's actually H equals to something, right? That's why we'll do 1 over slope. Now, what you need to do, you need to draw a straight line in this data point and find the slope. That's the task, first task, and that will give us N. Then we just need to find out A. Do you have a straight edge or something? Okay, use that to draw a kind of straight line, which will be, and you know all the rules about drawing the straight line or trend line, right? All the data points, like you need to make sure that you have kind of same amount of data points on both sides on average the same distance. Okay, this one is my one. On this one, we will find out the slope and then we will calculate A.